Okay, so here's the tricky thing that they solved in this paper. Their paper was about multiplication. Okay. So when I take the interval from 0 to 1 and I make products, what interval are those products going to be? Can you tell me? I pick two numbers from this interval. What interval, where are the products going to live?
Well, I think they would just live inside this interval.
From 0 to 1, that's right. Now when I remove the middle thirds, 0 to a third and 2/3 to 1, what do the products look like when I take the products from here?
Here I don't believe you can make all of them.
Alright.
Like, for example, it doesn't look like you can make 1/2.
Alright, we'll talk about that in a minute. Where do the products from in here live?
Well, the highest, if you take 1/3 and it gets you to 1/9.
Okay. So where do the products live?
0 to 1/9.
0 to 1/9. How about the products in here?
That's 4/9 to 1. We think.
Okay. Do you still think you can't make a half?
And now it looks like you can. Like, it looks like you can, but I don't see how to do
Well,
it.
you'd have to.
Well, we'll get there in a second. How about when I pick a number from here and a number from here?
So, the lowest number you can make is 0.
Okay.
And then the highest would be 1/3, it looks like.
Alright. So that sort of goes on top of this interval, but what's a number that we can definitely not make, or what's an interval we cannot make?
So from, as I'd say, 3/9 to 4/9, or
Right.
1/3 to 4/9.
From 1/3 to 4/9 becomes a problem. Okay, so right away we see we can't make the products work for the whole interval.
Yeah.
And what they proved in this paper is you have to pick 3 numbers rather than 2 numbers, and it works for the whole Cantor set. But let's wrap up by figuring out how we could make a half. That's a good question. How do I make a half? How do I choose 2 numbers in here to make a half? Now you can see right from the beginning that I can't choose a number from here.
Yeah.
So I got to choose 2 numbers from here, and I got to find something whose product is a half.
Well, I wonder if we can't kind of cheat a little bit, and we could use the square root of 2 over 2. Because the square root of 2 is about 1.4. So
Okay.
dividing by 2 is around 0.7, which is going to be in this interval.
Alright, so that's my first number, square root of 2 over 2.
And then your second number can be just the square root of 2 over 2.
Square root of 2 over 2. When I multiply those together, I get 2 on the top, 4 on the bottom, I get a half. How about something like 4/7 times 7/8? And the only question is, what is this going to be?
That is indeed a half.
This is a half. So the question is 4/7 bigger than 2/3? I may not have picked one that was good enough. Do you know what 4/7 is?
So so 1/7 is 0.142857.
So it would be 5. Would be
It's gonna start with a 5.
571428.
Yeah, which is
It's
smaller than
smaller.
2/3. And so that doesn't quite work. But you can imagine maybe I could construct some rational numbers that did work. Maybe if I tried it with 16ths.
Well, you could do 5/7 times 7/10.
Aha! 5/7 times 7/10. Alright, so 5/7 starts with a 7.
Yeah.
Right.
So bigger.
And 7/10 is 6. So there you go. Alright, cool. But you can see right away that the product problem is harder.
Yeah.
Yes.
Much harder. So, anyway, this is good. It's fun. And this was, by the way, this is a brand new math paper. Does it have a date on it?
November 23rd.
November 23rd, 2017. So mathematicians only just figured out this triple product thing
Last week.
last week. Good work, guys.